So in chapter 4, we are talking about something called matrices. All right, matrices is plural for matrix. So when you see a matrix is going to look something like this that you see on the screen. And a matrix is just a way of representing data. All right, so data could be, again, related to anything. Most times when you're working with these matrices, you're just going to see a bunch of numbers, but you really want to think about these numbers having some sort of real world representation. So for example, in this matrix, maybe the columns, right? I have 3 columns here. Maybe each of these columns represent a different day of the week, right? Maybe this is Monday, Tuesday, Wednesday. And then maybe these 2 rows, right? I have 2 rows here. Rows are horizontal. Maybe this is for 2 people, right? Maybe this is person number 1, and maybe this is person number 2. And so maybe this is data that we've collected, and we've decided to write this in a matrix. So maybe we could say like, oh, well, on Monday, person 1 earned $10. And on Tuesday, person 1 earned $3. And on Wednesday, person 1 earned $5. And so you can take this information, and a lot of times you'd maybe see it being presented on spreadsheets, like if you talk about Excel or Google Sheets. So you might have a whole list of information, and you can take all that information and put it into a matrix. All right. So a couple big things about matrices. The first thing is that we need to know about the elements, okay? So the way that we talk about an element is each one of these numbers are an element, okay? So each little position that it takes in the matrix is called an element. So the way that we describe this, now we can call this matrix whatever we want. So maybe let's call this, let's call it matrix C, all right? Matrix C, that's a capital C. We usually use capital letters when we're naming the matrix. Now, if I want to talk about this number 4 here, the way that I would talk about that number 4 is by saying what row it is in, and then saying what column it is in. All right, so the rule is you always start with the row, then you go to the column. All right, row, then column. Remember, rows are horizontal, and columns are vertical. All right, easy way to remember that is that columns are vertical. I think about like Roman columns, like on buildings, they're up and down vertical. So if I want to describe this number 4, this element, number 4, I could say lowercase c. Now lowercase c, 2, 3. The reason why I use a 2 and a 3, because this is in the second row, right? Here's the first row, here's the second row, 4 is in the second row. And then the 3 tells me what column it is. So first column, second column, third column, 4 is in the third column. So C23 is equal to 4 because 4 is in the second row and the third column. So let's try to think about what would I call number 3. All right, so pause the video, think for a second. What would I label that letter or that number 3 there? All right, and we should say that 3 is going to be lowercase c. It's in the first row and the second column. So 3 would be at location C12. All right, so that's how we use the elements, and we name the elements. And then we want to talk about dimensions. So just like we do rows and then columns when we're talking about the names of the elements, we also talk about the matrix in terms of rows and then columns. So this matrix C is called a 2 by 3 matrix, all right? So matrix C is a 2 by 3 matrix. Whenever you see this little X there, you want to say the word by. So literally, if I was speaking out loud, I would say 2 by 3. Now we write it as, looks like 2x3, but it's really a 2 by 3 matrix, okay? And remember what this means is that there are 2 rows, and 3 columns. 2 rows and 3 columns. So you can also think about, let's say we make a new matrix. Let's say I have something like this, okay? If we want to describe the dimensions of this matrix, we know we have to talk about rows times the number of columns, right? Rows by columns. So we have 1, 2, 3, 4 rows, and we have 1 column. So this would be a 4 by 1 matrix, okay? Now if we wanted to name this matrix, we can name it with a capital letter. So maybe we could call it matrix A, all right, something like that. And then we could talk about the elements, right? Maybe I want to know, where is this number 4 located? Well, I would say that 4 is located at A3, 1, because it is in the 3rd row and the 1st column, all right? So that's how we kind of name these elements and these matrices. And that is just kind of just a basic general overview of these matrices. So again, most often you're just going to see a matrix with some numbers in it. For example, let's say I have 2, 1, -4, -11, 0, and you can have whatever numbers in here that you want. Again, this is all really representing some sort of real world data, all right? Okay, so I could have a matrix like this. Most often you're going to see a letter in front. So we're going to say that, this is called matrix B, capital B. Anytime you have a equal number of rows and columns, so if the number of rows equals the number of columns, oops, there we go. This is called a square matrix. All right, so this would be a square matrix up here because it's 3 by 3. All right, it's the 3 by 3 matrix. We could also have, a 2 by 2 matrix. You can even have all the same numbers in there, right? If they're all ones, I still have 2 rows and I have 2 columns. So this would be a square matrix, all right? So just that's a very general kind of broad view of matrices. But let's say I go back to this original matrix up here, all right? So if I look at my original matrix, you might get questions like, which day of the week was most profitable? Well, if I don't know which day of the week was most profitable, I can add up these values on Monday, add up these values on Tuesday, add up these values on Wednesday. And so we might say that Tuesday is the most profitable because 3 plus 11 is 14, and the other days are all less than 14. I could also ask you which person was more profitable, person number 1 or person number 2. And if I add up person number 1, we get 18. Person number 2 only totals to 13. So we know that person number 1 was more profitable. So you're going to get some questions about these matrices, and you're going to have some problems where there's some context attached. Maybe it's days of the week and how much they make. Maybe it's the speed of a car and how far it travels. So you can have lots of different ways to describe this data. It just depends on what the data actually is. All right. One problem that you're going to see in the homework is it's going to ask you for a matrix such that AXY equals X plus Y. So let's think about what this means. This means that whatever my row is and whatever my column is, if I add the row and the column, that's going to be that entry, okay? So that can be a little confusing, but let's think about making an actual matrix, all right? So let's say I'm looking at this first entry here, all right? So this would be A11 because it's in the first row and the first column. So that means, based on what I know here, I have to add the 1 and the 1 together, right? This has to be 1 plus 1, because my rule is I add the X and the Y together. I add the row and the column. So this would have to be the value 2. So it'd have to be a 2 here. And then I could look at this box here, and this box is in the first row and the second column. Well, my rule is I add the row and the column, so 1 plus 2 would be 3. And then I could look at maybe this spot over here, right? This spot over here. Well, this would be in the second row and the third column, and so this would be 2 plus 3 is 5. So you're looking for, whenever they tell you the name of the element and they tell you what that process is, just perform that process, and then that's going to tell you what numbers to put in each of these different locations. All right, and that's kind of what you're going to see on the homework. This is just, again, a general basic overview of what matrices are. We're not actually doing any operations with them yet, but eventually we're going to get to a point where we can make systems of equations and solve them using matrices. We can also get to some kind of bigger word problems where we'll see how these relate to kind of real world